Good morning, students. I hope that all are in safe at your home. In BEIE subject, up to we have discussed three-phase induction motor. Now we are going to see the topic single-phase induction motor, and the topic covers introduction and construction of single-phase induction motor. The single-phase induction motor is a fractional kilowatt machine because they are rating start from 0.25 HP, 0.5 HP, 0.75 HP, 1 HP, 1.25, 1.50. So like that, it is a fractional kilowatt. So that it is a single phase induction motor is a fractional kilowatt motor. And the main application of this motor are homes, office, shops and factories like fan, washing machine, hand tools like drillers, record player, refrigerator and juice maker, etc. And the construction is very simple. And the drawback of this motor is lack of starting torque, reduced power factor and low efficiency. And single phase induction motor as the induction type of motor, and it is I already told you now that it is a fractional kilowatt horsepower, and it is classified as four type: resistance start, capacitor run and shaded pole induction motor. Now the construction of single phase induction motor. The main parts of single phase induction motor are: first one, yoke; second, stator core and windings; third, rotor core; and fourth one, shaft and other mechanical parts. And first part is yoke. It is made up of cast iron and it is highly mechanical strength to the internal parts. This is the outer yoke, and inside the part it is a mechanical support to the by using a clamp or screw. And stator core and winding. Stator core is made up of silicon steel lamination sheets, and it has several number of slots. So it is a laminated slots, and it is made up of silicon steel, so that the types of slots are open type, semi open and closed. So there are three types of slots available. And as a construction, it is a cross section view of single phase induction motor. And first part, yoke, already told you now. Then stator part, then rotor part, and in between the stator and rotor is a air gap. Then it is a rotor stamping, rotor winding. This is a stator winding. Stator winding is copper wire. It is made up of copper wire, and it is placed in the that provided in the slots, each slots, like lap winding or wave winding. And this is the base, and it is a connection of supply. The stator winding is connected to the input of supply single phase, so that the supply is given to the stator winding. Due to stator to rotor mutual induction, it will be rotate. This is a basic principle by double revolving field theory. Then History's losses and eddy current losses. These two losses combine is known as core loss or iron loss. By reduce the hysteresis losses, the flux density has to be reduced. To reduce the flux density, the flux path area has to be increased. So for increasing flux path area, number of stampings are used to form to core instead of solid core, so that it is made up of lamination sheets. Eddy current loss. Due to flux linkage, each stampings include a minimum voltage and a minimum circulating current. And to reduce the eddy current loss, all stamping insulated by thin layer of varnish coating, then stamped. And this is the without insulation and with insulation of stator winding, and stator winding insulated copper conductor to form a stator winding, and stator winding placed inside the slot and around the pole, and stator winding excited by AC supply. Already I told you the graph, circuit. And types of winding: lap winding and wave winding. The most of single phase induction motor are constructed by lap winding, and lap winding can be used for high speed applications, and number of parallel path is equal to number of magnetic poles. Whereas using wave winding, this can be used medium and low speed applications. And rotor construction is like this. It is also made up of silicon steel lamination sheets, but here it is a rotor slots. The slots have rotor conductor, and it is made up of copper bar. It is not a flexible wire, so that it is short circuited by end ring. This is the one end and this is the another end, so it is ended by short circuited by end ring, so that the resistance cannot increases. So this is the laminated core, silicon steel lamination sheets, several number of slots, and heavy bar of copper. It is not a flexible wire, and it is a short circuited rotor, so resistance is very small. External resistance cannot be connected to the circuit. So apart from this stator and rotor, the other parts, shaft and other mechanical parts. Solid iron bar used as a shaft, means a shaft is a center part of this located, and it is made up of mild steel, and provided mechanical support to armature and commutator arrangements. And also used to deliver the mechanical output and used to collect the mechanical input for motor and as well as generator. And cooling fan, bearings, centrifugal switch and end shields are placed around the shaft at both ends. So cooling fan for it is a cooling purpose. While running of motor, inside they are generated more heat, so that to reduce the heat, the cooling fan is provided. Bearing is to reduce the mechanical friction, so that it is placed both end of the end shields. Centrifugal switch. So here the single phase induction motor have two winding, auxiliary winding and main winding. At the time of starting, auxiliary winding and main winding included both. So after a fraction of second, the auxiliary winding will be disconnect by using this centrifugal switch. It is elaborated discussed in types of method. And finally, end shields. It is a protect the internal parts from external environment. So this is the construction wise. So next working principle we will discuss in next class. Thank you. So any doubt, please post your queries through WhatsApp group. Thank you.